I'm Dave Derrick. I'm a research hydraulic engineer with the Waterways Experiment Station in Vicksburg, Mississippi. We're on Camp Miakonda, Toledo, Ohio. We're doing a stabilization restoration project on the Ottawa River. This is Reach 1, which is the most upstream of all the reaches. We're going to work on reaches 1 through 4. Over on the right descending bank, we have a continuous bank protection, a longitudinal peak stone toe protection. You can see where the camera's going right in here. It's about 3 foot above base flow water surface elevation, which is the elevation of flow that we've got today. Actually, the river's flowing relatively slow today. It goes all the way around here. It's 390 foot long. We're at the downstream end. It's keyed up into the bank. Kyle's going to turn around and way up the hill, the bare dirt area, there's actually a trench. We dug a trench 5 to 6 foot deep, 5 to 6 foot wide. On top of the bank, you can see a row of vegetation. We planted that vegetation in there. That's mostly roughleaf dogwood. It'll take a good bit of shade. It also prefers to be up on that upper bank, that top bank. That's about 11 to 12 foot above base flow water surface elevation. That trench goes all the way back into the woods. It's about 25 foot long. It's continuous, so we dig the trench. We curve it so that it curves away from the stream at about a 20 to 30 degree angle. We put the vegetation on the side away from the river, on the bank side of that trench. We backfill that trench with stone. There's about 1.5 tons of stone. This is a type B stone, a size B stone. It's a 18 to 24 inch stone. And it comes all the way down the bank, and then it ties into the stone that you see here down at the bottom, the longitudinal peak stone toe. We backfill that with soil. We overfill that a little bit because that's going to settle over time. The longitudinal peak stone toe protection will give us a continuous protection all the way around for the 360 foot upstream. It's built out of a well-graded stone. By that I mean that we've got that top size, 18 to 24 inch stone. It's large, smaller, 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 smaller. The stone is designed to self-adjust. So we're going to place it, we're not going to dig down into the bed of the stream. We're going to place it on the bed of the stream. It's in a pyramid or a triangle. This is about 1.5 tons per foot, each lineal foot. And this stone is designed to, when the river comes in and hits that stone and digs down and scours a scour hole, then that stone is designed to adjust or self-adjust or launch or fall into that scour hole and armor that scour hole. So the stone is loose, and the gradation allows it, when it gets undercut, to immediately fall down into that scour hole and armor that scour hole. Greg's working over here putting in some live siltation. So we're going to build a big floodplain bench in here. It's about 50 foot wide. It's about 150 foot long. It's basically at a Q1.5 or a Q2 water surface elevation, so it should flood up on that floodplain and wet that periodically. The live siltation is continuous. We're putting in 3 plants per foot. That's a mixture of willow, sycamore, buttonbush, and dogwoods. We've got silky dogwood and roughleaf dogwood. So we're putting in 3 poles per foot, 2/3 in, 1/3 out, basically. So this is down 4, 5, or 6 foot. So we'll lay that up against that bank, and then with the tractor we'll come in and we'll backfill that area. When we backfill that area with soil, then it plants those plants. When the water comes out of the river and heads toward the floodplain bench, that floodplain bench, it's got to go through that vegetation. That slows everything down, slows the water down, so we don't have any erosion on that upper bank or on the floodplain bench. And it'll drop out sediment, it'll drop out seed, it'll drop out organics. So in a lot of cases, we'll get a little bit of deposition up in there. It'll build that bench up to a certain elevation, whatever elevation the river needs to build that bench to. And we've got really, really slow water in there. Live siltation slows things down, drops out sediment. The really low stone structure over here, this is Benway weir number 3. We've got 3 Benway weirs in here. They're 10 foot wide. They're 1 foot above base flow water surface elevation. And each one of them is about 16 foot long. They're indirect method or redirective method. The bow wag of the deepest part of the channel was up against the bank, eroding the bank. We've moved it out with the floodplain bench. We've moved it out with the continuous longitudinal peak stone toe protection. And then the Benway weir is going to move it out even further. So the longitudinal will give us basically a false bank line in here, moving the bank of the river out to the edge of that floodplain that we're constructing. And then the Benway weir will further move the bow wag. And the bow wag will be the deepest part of the channel, highest velocity. It'll be right off the end of these 3 Benway weirs. And we've got these lined up so that it comes off of Benway weir number 3, and it'll be a smooth alignment up against the right descending bank going on downstream. So it doesn't go over to the left-hand side. We kind of want to keep it on the right-hand side so it doesn't have any detrimental effects going down around this bend, which is relatively stable on that left descending bank. And we don't have any bank protection on either bank down in reach number 2. Okay, that's a wrap.
Action.
Okay, we're here at Camp Miakonda, Ottawa River. We're still on reach 1. We're at the downstream end. I'm standing on Benway weir number 3. These are upstream angled, low elevation sill. They were invented in 1988 by my boss at the time, Tom Pokrefke, for use on the Mississippi River. Mississippi River Benway weirs are anywhere from 800 to about 1,400 foot long, longer than 1/4 of a mile. On this section, in this specific area of this project, we're looking at something that's maybe 14 to 16 to 18 foot long. They're going to be angled upstream, about 70 degrees from the bank, measuring from the bank, or 20 degrees from perpendicular. That's going to be the same angle. So what you do is you come back on the bank and you set your angle. You come off the bank 70 degrees. It's really important to build the downstream side of this Benway weir out of really, really large stone. Very big stone right in here. We kind of build this a series of stones out here. We also make sure that the stones on the end are very large. Stones upstream and in the middle don't have to be quite as large. They're going to be in compression. They're going to push against the big stones at the downstream end. They're going to hold into place. Water's going to go over the tops of these weirs. As I said before, they're only 1 foot above base flow. What you want to do is have your water come over the top. They're a roughness component, so you've got water that's going to go in between. It'll go down. It has to climb up over these things. They act as a roughness coefficient. They're going to slow water down. Even when we've got 12 foot of water over the tops of these Benway weirs, the velocity over the tops of the weirs, that water velocity is going to be about 1/2 or less than 1/2 of the velocity of the water right off the end of the weir in the bow wag. So when we angle them upstream, water coming over the top of the weir is going to see this roughness, and it's going to leave this downstream edge perpendicular to that axis. Okay, so when you've got that downstream edge angled upstream, water's going to come in, see the roughness, slow down, and it'll get redirected perpendicular to that axis. If we angle these downstream, we kick all the energy and all the flow into the bank. Okay, good.
Okay, action.
All right, we've got the camera set up on Benway weir number 3. We're still on reach 1, Ottawa River, Camp Miakonda. We're looking straight upstream. I'm standing off the end of Benway weir number 2. It's about 16 foot long. I'm standing right in the bow wag at high flow. This is where we have our highest velocity coming through. Look upstream and you can see Benway weir number 1, and then you can see the longitudinal peak stone toe protection. We do not have the live siltation in there yet. The large plant that's arching out over the stream is a living locked log. That's angled downstream about 30 degrees relative to the bank. Up over the top of the water, obviously. It will grow branches branches on the upside, all the branches on the downside will die. And it'll give us a whole bunch of shade, cover, insect reduction, carbon into our stream system, probably 20, 25 foot out over the top of the stream. We've got several of them in here. It's kind of a recent invention, so we're going to be studying these to see how well they work. We've used them in a couple other sites and they've worked really, really well. The Benway weirs, the 3 Benway weirs in here are designed to capture flow coming off the longitudinal keystone toe protection. The bow wag will be right up against the ends of these Benway weirs, so the deepest part of the channel would be right where I'm standing, off the end of the weir. What we wanted to do with these was obviously slow down velocities and take a lot of the energy away from the right descending bank, and that'll actually transfer a good bit of that energy over here on the left descending bank. So right in this area, since the other bank was eroding, this point bar had built out. In fact, it's built out. There was a big log jam in here a couple of years ago. They removed that. When we were out here in July of 2009, this left bank that I'm standing on was almost 90 foot back from where I'm standing on this edge of water. This whole area is filled in, and then it continued to erode on the right descending bank, so this part of the point bar is built out. What we want to do is take some of the energy from the other side, right descending bank, put it over here on this left descending bank. This is all annuals. There's a little bit of peat gravel in here, but most of it's sand, silt. What we want to do is put enough energy in here and remove some of this material off the point of this point bar. So we want our new edge of water to be right here in this area, coming right through where I'm standing. So we're going to redistribute that cross-sectional velocities in this bank. Have higher velocities over here, lower velocities up against the right descending bank, and shave this point bar off of this left bank. What we want to do, they're going to look right downstream. Kyle's going to turn the camera a little bit more and look downstream. That bow wag lined up with Benway weir 1, 2, 3. It's going to touch right in here. It's going to come off of Benway weir 3. And it'll be right where those vines are hanging over the river. They're going to be right up against that right descending bank. What we want to do is have a long crossing in here from the right descending bank, and then it's going to take a while for the river to flow through that crossing and cross over to the left descending bank and go around Benway number 2, which is an unprotected Benway. So I talked about the living dike. Okay, y'all can tear it up. We're going to go way on up to the upstream end and start filming a little bit.
Make some noise, guys. Trying to get the salix out of them for aspirin.
Okay, we're still in Camp Miakonda, Reach 1, Ottawa River, extreme upstream end of this section of the project, Reach 1. I'm standing right where the key starts to turn and go up the bank. So the river's coming in here to my right. The right descending bank's coming right in here. I want this key to be at about a 20 to 30 degree angle. That's really, really important. So when you can see the live siltation, you can see the longitudinal peak stone toe protection, and then it goes up about another 30 foot, goes all the way up to the top bank, ties way back deep into the bank. This upstream key is really, really important. It's going to be the most important key. The key's got one job: to tie your protection works back into the rest of the world, not let your river get in behind your project. So, same as the downstream key, we're going to dig the trench, put the vegetation in away from the river on the bank side, put the stone in 5 to 6 foot deep, 5 to 6 foot wide, 1.5 tons per foot. Put the veg in, put the stone in, put the soil in, soil choke it, fill, overfill so that it's going to settle. We want that angle so that if this river ever changes direction upstream, if it ever starts to erode this bank, this right descendant bank, when the river moves over, if it would ever attack this key, well, number one, it's got to get this log out of here. We left this in place for a little bit more stability. But if it comes in here and erodes this bank, it's just going to hit this key at a relatively soft angle. It's just going to bounce off of there. If I take this key and go perpendicular straight up the bank, back over here, 20 foot away from this area here, if I just got a wall in there, that river's going to, if it moves over, it'll come in and hit that wall, fight that stone, dig down, undermine that stone, and then it'll breach that wall. It'll go through that wall and go through the middle of the project and fail the project. I'm going to walk up here onto the floodplain bench, and I'm going to talk about a living dike. Okay, I'm still on Reach 1, Ottawa River, Camp Miakonda, Toledo, Ohio. I'm up on the floodplain bench. So this is designed for the water to come up, flow up over the top of this bench, utilize this area, wet this area. We're going to put in plants that really love water, the willows and the dogwoods. Buttonbush will be planted in this area. And I always want to plant on a grid. So I've got my stone right up against the river. I've got my live siltation up against that stone on the back side of the stone away from the river. I've got my key going all the way up. It's vegetated all the way up the top bank. Then I'm going to put in what's called a living dike. This living dike right here goes perpendicular to high flow. When I'm looking upstream, this whole river is filled full of water, comes down through here at high velocity. It's got to go through that first row of vegetation, slows down, drops out sediment, drops out seed, drops out organic. Then it meets this living dike right here, perpendicular, built out of willows, dogwoods. It's basically like flowing through a picket fence. This water's going to come through here, hit this, slow down. I've got a whole series of these all the way down through the project, perpendicular to flow. Water comes in, slows down, even to exit out and go back out into the river, it's got to go back through that live siltation. That's going to slow it down again. That's what we want to do. Slow that water down. These areas right in here, we're going to put container plants, a whole bunch of different species of plants. If you don't protect them with your live siltation and your living dikes, plant your 3-gallon container plants, nursery grown stock. If you get a big flow in here, that stem sticking up is going to get covered with leaves. The leaves are going to form a wider area. Water's going to hit it. It's going to push that plant over. It's going to pick it up out of the hole, and it's going to float it downstream. You're going to lose all of your plants. That's a wrap. We're still on Reach 1, Ottawa River, Camp Miakonda. We're in the middle of the project. We're looking upstream. You can see that we've got the live siltation in, longitudinal peak stone toe protection. No bendward weirs in that area. That's really, really narrow and deep through there. You can see that we have not backfilled that area yet. That will be filled up to the top of the longitudinal peak stone toe protection, floated back up that bank. Right in front of us is one of the living lock logs. So the camera is going to come around to the, there's a lock log in here that's underwater, comes off of bendward weir number 1. We probably can't see that. We've got bendward weir number 1 in here. That's the shortest one. It's about 10 foot long. Living lock log is leaned out over the stream. It's going to give us a lot of shade, cover, structure. Right where I am, you can see that we've got a section of longitudinal peak stone toe protection. We're working our way back out. We've built the entire floodplain bench. It still needs some vegetation. That's not done yet. We have not put in the live siltation here because we're still getting equipment in and out. I'm standing next to one of the living lock logs right here that's leaning out over the stream. We've got a really good angle at it. You can see that it's up and over the top. Branches on the top will grow, branches on the bottom will die. We've got it at about a 30-degree angle to the bank. That way, even when you get flood waters, it's up around the tree. We're at such a good angle that it's going to shed a lot of the debris. So we specifically put it at that angle so that you don't capture a lot of debris on the upstream side of these living lock logs. Right in front of the camera, right in front of me, you can see that we've had a really, really hard time in here. This is a really low elevation area. It was pretty swampy. We put in a number of logs. We probably put 70 or 80 logs in here. They're underneath this area. It's almost like a floating road, just so that we could get the equipment in here and we wouldn't get stuck. Over again, I'm standing on the floodplain bench right now, over against the right-hand side. That was a vertical bank in there. We've sloped that out with soil. It's still relatively steep, and we're worried about if water came in here, dislodged some of that soil, and that soil crept down slope. We wanted to capture that. So we've got a whole fence in here of large willow. These are anywhere from about 2 to 6 inches in diameter. It's continuous. We've got one per foot. It's going to ring this entire floodplain bench up against the bank, all the way around from where I am, all the way down around, all the way to where it ties back into the downstream key and ties back into the river. We've got 3 more living dikes that we're going to put in here, similar to what we talked about upstream. Those are not in yet. This one living dike right in here is actually part of a key. So that's a perpendicular key, goes straight back from the longitudinal peakstone toe, ties into the bank, goes up the bank, vegetated all the way across the floodplain bench, all the way up the bank, all the way in the woods, back up into top bank and into the woods. So if the river comes in here, erodes this soil, we've got this stone trench full of, stone that'll stop the river from scouring out in this floodplain bench area. But we're going to put enough vegetation in here that's really not going to be able to happen. Done.